Hello everyone. In this video, I want to explain to you the most important AWS services. If you're just getting started with AWS, it's easy to feel overwhelmed. There's over 300 different AWS services out there. But the truth of the matter is, nobody knows all of them. In fact, there's 50 or less services that you need to know about, with even fewer that you need to know well, in order to be an effective AWS practitioner. And so what I wanted to do in this video is to explain to you which services you need to know about. And the way I want to do this is to take a practical example. Let's imagine that we have an e-commerce application, maybe something like Amazon.com. Now let's run through the different components that we need for a successful internet application in the context of AWS. So of course, everything with an internet-based application starts with a web browser, and you need to use your browser to navigate to a particular domain. That's where AWS's Route 53 service comes into the picture. Route 53 is a DNS, domain management, and traffic management service. So for example, if you want to navigate to a website like Amazon.com, for instance, in order to do that, you need to register that website with Amazon Route 53. Now, Route 53 is also another very interesting service because it allows you to set up health checks for your infrastructure that is behind your URL here. So say, for instance, you have a compute layer behind this Route 53 endpoint. You can set it up so that it's pinging these different servers that exist behind that endpoint to make sure that only the ones that are available and stable are the ones that are going to get traffic routed from the internet. Now, typically you wouldn't point your DNS directly at servers. You would usually point them at load balancers, but that's a topic discussed more in an upcoming section. Now, some other important details of how you can control the flow of traffic using Route 53. Now, you can create geographic-based routing rules so that incoming requests are forwarded to the closest physical region to optimize user experience. You can also set up latency-based routing so that requests always get forwarded to the location with the fastest latency for the specific user or application making the request. And you can also set up failovers, which are important for system stability, to ensure that if the infrastructure behind an endpoint fails, traffic can be distributed to other healthy resources. So that's a little bit about Route 53, a very useful service that you use to set up your different domains. And so that now that we have the internet hitting our endpoint here, the next step is how do we serve our content, right? Our static content. So static content can include stuff like images. It can include stuff like the HTML for our website. It could be, a variety of text files, whatever you really need that's kind of fixed. You need a general storage engine in order to save all of that, right? And so that's where Amazon S3 comes into the picture. So Amazon S3 is a general blob storage service. Now, S3 is extremely flexible. It allows you to store all these different file types that are relevant for your application. So very useful in the context of website hosting itself. But because it's also so flexible and so dynamic, it's also allows for other integration into other AWS services that we'll talk about a little bit later on. Things like event processing, for example, or things like, say, if someone uploads a file into S3, you'd like to trigger some kind of event using another AWS service. All of that stuff is supported in S3 as well. Now, we're going to come back to S3 a little bit later, but for now, all you really need to know is that when you want to serve up your static assets for your website behind your URL endpoint, that's where you'll use S3 to host all of that. So S3 is very versatile and it's very cheap and inexpensive. However, if you imagine a scenario where you want to host a globally available application, when you set up your S3 bucket, you need to choose which AWS region that you want to put your resources in, your HTML, your JavaScript, your CSS, all that kind of stuff. So that means that if someone lives in North America, say over here, and the website is hosted over here in EU West 1, for example, there's a lot of network latency that the user is going to experience if they just use the S3 bucket with the contents that's located in EU when they are in North America. And so in order to bypass that, you need some kind of regional caching, right? So regional caching and replication, which is what AWS CloudFront is all about. Now, CloudFront allows you to very easily integrate with Amazon S3. S3 so that you can say, I want to host all of my content in S3 itself. However, I want CloudFront to replicate all of that data to all these different regions all across the world. And then depending on, where the user is, so you have a user over here, a user over here, and a user over here, the traffic is going to get routed to the most appropriate location. So for example, this one would go to this user would go to this CloudFront distribution, and this user would go to this CloudFront distribution. And you could set up a whole bunch of different rules on how you want your traffic to be routed, whether it's geography, whether it's based on just latency. So there's definitely a lot to it. So let's just get rid of that really quick. Okay, so now we have a good understanding of just general asset hosting, how to get your CSS, how to get your HTML, those kind of fixed resources into AWS. What's next is going to be your APIs. These are the things that add smartness to your application, being able to request data on the fly as you need it in your web application. And so the primary service that you'll usually be working with fairly regularly, this one is called Elastic Load Balancer. There's also an application load balancer variant as well. And the purpose of this component is to allow you to horizontally scale your application. So what that means is that if you're a user over here and you want to call some kind of API, there could be many different pieces of infrastructure that are behind the scenes here. But from you as a user, you just call an API that gets forwarded to a load balancer. And then your load balancer can decide which instance do I want to forward this traffic to, right? This is your typical request response model. And with this load balancer, it can decide, which instance do I want to send this stuff to. You can also set up things called auto scaling groups to add more instances as needed and then add them to the group so that more traffic can be distributed as well. You can also, take them away if need be, if there's periods of low traffic. It also supports sticky sessions as well. So if you're doing things like WebSockets, can be very, very handy. Load balancers are just ways to distribute your traffic to multiple different underlying compute nodes that are behind the scenes. Okay, so let's just get rid of that so we can move on to the next API layer. And the next one is actually one of my favorite ones, and that is called API Gateway. Now, API Gateway is a more managed API-based service. When people describe it, they usually say it's the front door of AWS. And what I mean by that is that usually people will use it where, you set up an endpoint that points to an API gateway, and then behind the scenes, there's like some kind of compute instance over here that you can forward it to, right? That's totally well and good. However, what's interesting with API Gateway is that not only can you set it up to send requests to compute, but you can set it up to forward to all other different types of AWS services, right? All other different variants where you don't need a layer of compute in the middle. You can basically just effectively call AWS services through a RESTful endpoint. Now, other features, if you do choose to use APIs with API Gateway, is that you get access to things like rate limiting. So you can say certain users that are using certain keys or access keys, I guess you could say, are only allowed to request maybe 100 requests per minute on your API. You can set up throttling. You can set up user permissions as well for your API gateways. There's also a WebSocket variant that you can use as well. So there's really a lot when it comes to API Gateway. It's a very, very powerful service. I typically use API Gateway over load balancers. In fact, just normal load balancers are more appropriate when you have services. Well, we'll come to that. I don't want to spoil it really quick. But essentially, API Gateway can be used with anything where load balancers are kind of constrained in terms of what underlying compute layer that you'd like to use. Okay, so that is a little bit about API gateways. Now I want to talk about very briefly security of these APIs, right? Like how do we ensure that users aren't taking advantage of what our APIs can do in terms of the functionality that they provide? So in order to address that, there's two different AWS services. The first one is WAF, which stands for Web Application Firewall. And the purpose of this service is to protect you from things like bot attacks, where you're having users try to scan essentially your endpoints to figure out different vulnerabilities, protects you from users trying to exploit the logic in your application authentication endpoints. So for example, like SQL injection, these are the types of things that WAF helps you with. It also allows you to ban or prevent certain users with certain IP addresses from hitting your endpoints, just general management of your endpoints. Okay, so that's what WAF is used for. Now, if you like protection against distributed denial of service attacks or DDoS attacks, that's where you're going to use AWS Shield. Now, they do provide a free tier where they protect you from DDoS attacks. However, there is a paid tier, which is a costly $3,000 a month, $3,000 US, which is pretty bonkers. Suffice to say that it's predominantly used for mission critical applications. So I wouldn't worry about this if you're just kind of a small application or testing things out. But if you're like a big website, your app needs to be up and running 24/7. You can't afford to be hit by bot attacks or DDoS attacks. Then AWS Shield Advanced tier is what you're going to want to go with. They also provide 24/7 monitoring, 24/7 access to AWS support, certain cost incentives too. If you do get attacked with a DDoS attack, they'll refund you portions of the cost. So there's a lot to AWS Shield that can be useful to some users that really want to maintain a mission critical application, right? So just drawing out the rest of our diagram here, we have WAF, which protects us, and then we have forwarding to our API layer here. Okay, now let's move on to a couple other smaller things. Similarly, in the terms of security, there's also Certificate Manager. Certificate Manager allows you to ensure that your endpoints that are hosted in Route 53 have a valid certificate. So this also means the traffic that is flowing from your user over here and your API is going to be encrypted end to end. So you're not going to be able to have any user here sitting in the middle intercept your traffic and be able to read it, right? So you can get certificates issued by AWS, or they also allow you to use another domain or certificate authority rather, in order to set them up through AWS's console. So that's what Certificate Manager is all about. Now, so far, when we've talked about our different APIs here, in everything that we've described, there's nothing stopping a external user out here, like someone that you know or don't know, from calling your load balancer endpoint or calling your API gateway endpoint, right? And so in order to add a layer of authentication and authorization, that's where you need Amazon Cognito. And what Cognito allows you to do is that it allows you to basically create a pool of users, and then users need to register in your different pool, right? So you force them to register. And when a user logs in to Cognito, basically Cognito will return that user a token. This is all done through the application layer, for example. So you don't really need to know about this too much in detail. And then when the user's web browser has this token, it calls your API gateway endpoint with that token. And that's how the API gateway endpoint knows that this is a valid user. I should let this request through, as opposed to it being either a malicious request or a user that's not providing a token at all, so an unauthenticated user. So that's for authentication, figuring out who the user is, but Cognito also supports authorization as well, which is what permissions does a user have access to. And the way it does that is that you're allowed to inject or associate different attributes onto your different user that's in your user pools and say, this person is an administrator, or this person is a student, depending on what your application context is. And then you can say, depending on what they are, then an admin has permissions to everything, whereas a student has a permission to like just a subset of everything, right? And so that's what Cognito allows you to do. It allows you to facilitate both authentication and authorization so that you can secure your endpoints so that only valid users are able to access them. So that's the story with Cognito. So let's move on here. Okay, so we've talked about APIs, we talked about securing our endpoints. Now what happens when you want to actually add some kind of compute behind these APIs, right? You want to add something that's going to be able to perform some business logic, something that's going to be able to insert stuff into databases. How are we going to actually do that? And so what we need in order to do that is a compute service, right? That's what compute is all about. It allows you to implement like functionality in your service. So what are the different popular AWS services there? So the most popular one and the most classic service that you can think of is EC2, or Elastic Compute Cloud. And EC2 is a type of service service where essentially you rent instances from AWS. Now, these are virtual instances. You can also rent dedicated instances if you like as well. But when you set it up, you can choose like what type of operating system do you want? Do you want Linux? Do you want Windows? Do you want something else? Now, the thing with EC2 is that it's extremely flexible, but you also need to worry about things like patching, things like the availability of your instances. You need to tear them down when you're done using them. So although they are very cost effective and very flexible, there's a lot of administration that you need to do in order to maintain it successfully and also keep your costs relatively low. So all of that setup isn't really fun, isn't really stuff that people usually want to worry about. And that's where the other option here comes in, which is AWS Lightsail. Now, Lightsail is actually the solution that I use to host my own personal website, which is beabetterdev.com. And the reason I like Lightsail is that it's kind of like EC2 for dummies. It allows you to set up very simple applications with predefined templates. So for example, my website uses WordPress, for instance, right? And WordPress is a very popular content management system. So when you're using Lightsail, they make it super easy to set all that stuff up. It's honestly like a dumbed down version of the AWS console where it's very guided, it's very involved. You do pay a premium over something like EC2. However, that premium is worth it for a lot of users, including myself in this context, because I don't want to have to think about all the setup, all the maintenance, all the extras that go into maintaining my own EC2 instance. Now, Lightsail also supports Microsoft operating system. You can set it up so that you can host Docker containers in there. You can set it up so that you can host databases. There's a lot going on in the Lightsail service that I think is very attractive to a lot of new AWS users. If you're a new user and you want to set up something quickly, Lightsail is definitely the way to go. If you're more experienced and you're trying to set up like an application that's actually going to be used for like a web app, for instance, or a backend API-based service, then Lightsail is probably not going to be for you. Okay, so that's EC2. Let's talk about our next compute service here, which is Elastic Container Service. And so what Elastic Container Service solves for is that it allows you to host and deploy containers into the AWS cloud. Now, you can also do this with EC2, right? You can create a container, like a Docker container on your home machine, and then you can upload it onto your EC2 instance, and then you can set it up and install everything and then run it. But there's nothing keeping like that container run. There's nothing monitoring its state, monitoring its health checks, stuff like that. That's what ECS provides, right? So it gives you that ability to not only deploy containers, but manage the life cycle of those containers as well. Now, you can either deploy your containers via ECS onto an EC2 instance. This is a more complicated model that I don't suggest. Or you can use the alternative, which is Fargate. Fargate and ECS go hand in hand. Fargate is basically a serverless variation of running containers. So instead of pointing it to a particular autoscaling group for your EC2 cluster, instead you just say, hey, I want to run like 5 tasks, for example, and then you let AWS know that, and the Fargate service worries about setting up those 5 different tasks. So you don't actually need to worry about where they are hosted. You just know that they are hosted somewhere, and AWS is handling that complexity for you. So that's what Fargate is. It's kind of the serverless variant of ECS. Now let's move on to the other variant of ECS, which is EKS, or Elastic Kubernetes Service. So there's not much more to say with EKS. It supports Kubernetes as opposed to just normal Docker containers. So if you're embedded in the EKS ecosystem, I encourage you to check this out. I'm not a big EKS guy myself, but for those of you that are, I'm sure you'll appreciate this. I believe you can also use Fargate in combination with EKS, but don't quote me on that. You may want to double check. Now, leaving the last compute service, which is my favorite, which is AWS Lambda. And this is, in my opinion, the most popular compute service that exists out there. Now, what Lambda allows you to do is that it allows you to write functions, and functions are just kind of pieces of code. And so you deploy these pieces of code into AWS Lambda. And then behind the scenes, Lambda will take that piece of code and put that on different pieces of infrastructure for you. And so when a request comes in, for example, to the Lambda service, Lambda will decide, where do I want to send this request to? You as a user don't really care about this at all. You don't even know this is happening. You just know that people are making requests, and behind the scenes, Lambda is scaling things up and down as it needs. And so that's what Lambda is all about. It's completely serverless, kind of medium to low flexibility, but extremely, extremely low maintenance, very easy to use. You can use it for API-based services like we were just talking about. You can also use it for event processing-based services. So if you want to process messages from a queue, for example, Lambda is great for that. And it's also very tightly integrated with a whole bunch of other AWS services. For example, some that we've already talked about, S3, for instance. You can set up an S3 and Lambda integration such that every time a user uploads a file into S3, you can trigger a Lambda function. And then that Lambda function can read the contents of that file and then do something else with it. You can also set it up so that when a user signs up for a Cognito user pool account, you trigger a Lambda function with the details of that user as input to the Lambda function's code. And then you can do something in your application over here, your Lambda function, and then maybe save more details back to that user's profile in your Cognito user pool. You can also directly integrate your Lambda with API Gateway or with load balancers. There's so much that you can do with AWS Lambda. I actually have a course that teaches you the fundamentals of AWS Lambda. It's over on Udemy. It's called AWS Lambda Practical Guide. I'll leave a link to it in the description section below in case you want to check it out. But extremely, extremely, extremely powerful service that more people need to know about and use. Okay, let's keep it moving here. We talked about our compute services. Two others that I want to talk about really quick because they are related to compute. They are about storage. And there's two here that are worth mentioning. The first one is EFS, which stands for Elastic File System. Now, the deal with EFS is that you can mount an EFS drive to one or more EC2 instances or any kind of piece of infrastructure. And so the typical application or the typical use case for EFS is stuff where you have static content that's stored on a drive somewhere and you want to share that across multiple different instances. Okay, so that's what EFS is all about. It's all about sharing content on a drive to multiple different compute instances. And then the other kind of partner or the other service that complements EFS is EBS, which is Elastic Block Store. And this service is more in terms of, it's kind of like an actual hard drive. You can only use it for one EC2 instance at a time. So it's more suitable for things like databases or transactional applications where you need to guarantee consistency, or you need really high read-write throughput on a hard drive. Think of it like an SSD that's attached to your EC2 instance or your ECS container. That's what EBS is all about. Okay, so that's it for just general storage. Now I want to talk about configuration and secret storage, which is a very important kind of security thing that you need to do in order to ensure that you're not leaking credentials anywhere. So the first thing that I want to talk about is, where do you store in AWS your secret keys? So say, for example, you have a secret key for, I don't know, things like a Gmail API, for instance, or things like a Coinbase API, right? Usually when you register with these kinds of applications, you register with them, they give you a user key, and then you need to store that user key somewhere because, you've paid for it and you don't want other people to access it, or else they can use it and then cause you to get charged some ridiculous amount of money. And so where do we store those different secrets, those different credentials? Well, the service that we're going to use for that is AWS Secrets Manager. So not really much to say about this, except that you can add different secrets, you can ensure that they're encrypted, and then from your compute application, you can access those secrets via a name, and then pull those down and then kind of use them when you're calling the corresponding APIs. Okay, so that's what Secrets Manager is all about. It's guarded very closely by different permissions. So usually you only allow certain users to access the raw secrets, so to see what the true values are. Typically you'd set it up so that from your application perspective, it doesn't need to know what the value is, it just needs to know how to get it, and then your application is coded up in such a way that it knows how to use it. Okay, so that's what Secrets Manager is all about. Now, the next popular thing when it comes to config is feature flags. Now, feature flags allow you to add code in your compute layer to say, you have a function that's running, but you're testing a new feature, for example, and you want it to branch off when this new feature is enabled. And then when it's not enabled, to go take its normal path, its normal course of action. Okay. So the way that you would typically do this is that you would add some kind of if statement in here, right? Based on this decision window. And if this thing is true, you go this way. And if it's false, you kind of go the other way, right? So that's what a feature flag allows you to do. It allows you to have kind of both paths of code in your application ready to be invoked. However, you have this flag that exists outside of your compute service that you have access to, that you can control and turn on whenever you need to. Okay. And so the service that allows you to do this is AWS App Config. And AWS App Config, you can either call it directly from your different compute layers. There's also different agents that you can install alongside like an EC2 instance, for example, where the agent will continuously pull from app config to get the most recent value. This reduces costs and also keeps it so that your compute has the most up-to-date value a lot more often, as opposed to kind of you checking it once a minute or something. So it handles the complexity of pulling that feature flag down and ensuring that you're using it in your application. Okay, so we talked about APIs, talked about config, talked about compute and storage. So now we can kind of start to complete this picture here. So we have APIs, we have a request coming in that are hitting those APIs, which are calling some compute layer. Now, compute layers aren't very powerful unless you have some kind of database behind the scenes that is actually storing some state or some data that your compute layer can use. And so what are the different types of databases that exist on AWS? Well, it turns out there's a lot of them, but you only really need to know 5 or 6 or so. And so the first one in the flavor of relational databases is RDS, AWS Relational Database Service. And this service allows you to configure a bunch of different types of databases. So there's like MySQL. You can also set up Microsoft here. You can set up Oracle databases if you'd like as well. And the reason that you'd want to use RDS over just kind of deploying a database onto something like an EC2 instance, for example, is that RDS kind of handles all the management of your database for you. It also has some extra features like multi-AZ, so being able to host your database in multiple availability zones and multiple regions if need be, in case, God forbid, any of those go down. Also supports things like auto scaling, both in terms of your database storage engine itself, the instance that it's hosted on, and the storage of it as well. And there's a whole bunch of sophisticated monitoring tools that you have access to when you're using RDS. So very, very powerful. Now, another popular relational database service that's compatible with both MySQL and Postgres is AWS Aurora. And Aurora is an in-house developed relational database built by AWS. It's compatible with MySQL and Postgres, like I mentioned. Now, the thing I really like about Aurora is that it supports a serverless variant, serverless, which, as we chatted about earlier when we were talking about AWS Lambda, you learned that I love serverless in general, and I also love Aurora for the exact same reason. Serverless databases make it so that you can scale all the way down to 0. So when you're not using the database, you're going to get charged absolutely 0. And then when lots of users are hitting your database, or you're getting an influx of API requests, it will be able to scale that database up to however many instances you need. And you can control both the floor and the ceiling. So you can say if you want it to go all the way down to 0, and however many instances you want it to scale up to if need be. So Aurora is a very, very popular relational database service that I highly encourage you to check out if you're using relational. And if you're not going with relational, you're probably going with a NoSQL variant. And the most popular one, at least today, is DynamoDB. Now, DynamoDB is an extremely fast and efficient key value store. It's fully managed by AWS. You don't think about instances. You don't think about provisioned resources at all. All of that is handled for you. And the good thing about DynamoDB is that it's extremely predictable and really optimized for key value lookups. Okay. In fact, Dynamo is used by many of the internal applications that exist inside of Amazon itself. In fact, DynamoDB internally, don't tell anyone this, actually powers stores other AWS services. So like things like EKS and things like maybe Lightsail, for example, to store the state there. So DynamoDB is extremely popular if you're going with a NoSQL database. Now, the other option is DocumentDB. So if you are a MongoDB type person and you like using that variation of NoSQL, then DocumentDB is what you're going to want. It's also a fully managed service, so nothing really to worry about in terms of administration. So what this gets you over kind of hosting your own MongoDB instance on like EC2, for example, is that management aspect, right? So not worrying about any patches, any updates, you just kind of set it up, configure how many resources you want, and you're good to go. Now, also for NoSQL is our final option here, which is Keyspaces, which is the Cassandra managed version of a database. Okay, so same idea with MongoDB, except that it's managed for Cassandra. Okay, now on top of these 5 databases, there's 2 others that also are important, but less popular, but just good to know that they exist. So the next one that I want to chat about is AWS Neptune. Neptune is a graph-based database. So this is applicable for certain use cases. Think Facebook, for example, right? Where you have like a friend, or actually this is you, and then you have a friend or a list of friends, right? And so how do you represent this kind of relationship between people, right? And so the natural way to do that is with a graph, and then like those people have different relationships with each other. And so how do we kind of set all this up? Well, you need a graph-based database, and that's what Neptune allows you to do. And now using Neptune, you can perform analytical style queries, for example, who are the friends of my friends and who is the most active in my application, for example, or more transactional kind of queries where you want like very quick results that are not analytical in nature. Okay, so it supports those 2 different variations, and there's different libraries that you can use to actually invoke your Neptune database, but that's what Neptune is all about. Now, another one that's very popular, not typically used as a database, but more for an analytical tool. Typically, you'll see it used for log aggregation and log analysis, which is AWS OpenSearch, effectively a rebranded version of Elasticsearch, for those of you that have heard about it. But AWS and Elasticsearch had a kerfuffle over licensing, so they basically forked it at a certain point and renamed it, and now they own OpenSearch. So a lot of the features are kept in sync with typical Elasticsearch. So, for example, there's a Kibana dashboard that you have access to, so all of that is available. But OpenSearch is a really powerful database that's NoSQL based, but typically usually used, like I said, for analytical purposes or search engines or like fuzzy searches for keys. So when you're searching on Google, for example, how it gives you that autocomplete, that's really where you'll see it used a lot. Okay. Now, in addition to that, there's also DMS, which isn't a database in itself, but it's kind of like a support tool used to move data between different locations or to migrate different databases, right? So say, for example, you have a data center in your local office and you're trying to get onto AWS. Maybe it's like a Postgres database, for example. You're able to use DMS or database migration service to basically get this stuff into AWS and then host that database onto something like RDS. Okay, so that's what DMS is all about. Okay, now also in terms or related to databases is caching. Now, caching, for those of you that don't know, is just a way to keep different pieces of data in memory, not on disk as you would see in a normal database, so that you can access it much faster. And there's 2 real options that you're going to need to think about when you're using or deciding which caching solution to use. The first one is called Elasticache. Now, Elasticache is a managed service, and you don't really need to worry about much when you're using it, but what you do need to worry about is how many nodes that you want to set up and what are the size of these different nodes. Do you want a T3 micro? Do you want like an M6G extra large? So depending on the size or depending on the node that you choose, the cost of Elasticache can be very, very different. Now, it also supports both Redis and Memcached, which are 2 different kind of caching libraries. Redis is by far the most popular one though. So you do have those options available to you. Now, the unfortunate part about working with Elasticache is that, like, say you have these instances, if this instance ever goes down or both of them goes down, basically your cache is purged. Nothing is in your cache. So your application layer will need to go and read from the database again, and then go and, like, when a new node gets set up, rehydrate the cache. And this can lead to a ton of requests to your downstream dependencies and cause problems for them. And that's where the other variant for caching comes into the picture, which is MemoryDB. So MemoryDB is another caching service that also supports Redis. Now, the main distinction between these two services is that Elasticache will lose all state when the nodes go down. However, in MemoryDB, when the nodes go down, it doesn't matter because the data is written to a replication log that contains the state of the cache at any point in time. So when the node gets replaced or comes back up, all of the data that was in the cache will be restored to its state. So it can almost be used like a database, although it's not really a database. Both of these services allow you to retrieve cache data in microseconds as opposed to milliseconds, like you would see in a bunch of these different other solutions up here. So that's really where caching comes into the picture. All right, let's move on now to some other services. I want to talk about AI or artificial intelligence. The first service that I want to talk about is AWS or Amazon Bedrock. Bedrock is kind of one of the most popular AWS services these days, just because of AI is super popular as well. Now, what Bedrock allows you to do is to interact with different foundational models, FM. So things like Facebook's Llama or Anthropic's models, or like, I'm not huge into the AI scene and all the different foundational models, but there's a ton of different models that Bedrock allows you to interface with. And then once you decide which model you want to use, you can set up things like chatbots, you can set up things like image generation or voice generation, things like this. Bedrock is more aimed at application developers as opposed to scientists. So if you're a user of AI, then you're going to want to use Bedrock for these kinds of applications. However, if you're a scientist and you want to develop and deploy those models, that's when AWS SageMaker comes into the picture. Now, SageMaker is, like I said, meant for scientists, and it allows scientists to develop models within the SageMaker ecosystem, to train those models, deploy those models, and also maintain those models. So that's what SageMaker is all about. I'm not an AI scientist. I don't know a lot about developing models themselves, so I can't tell you too much about it. However, I have used SageMaker for hosting these models that I've interacted with from my application layer, and I can tell you it works really well. Now, the remaining three services are kind of just like very niche services that are for specific things. So this one is called AWS Recognition. AWS Recognition is all about image and video detection. So being able to analyze different images and telling you different details about them. So you can detect faces, detect emotions. You can look at text or detect text, detect the context of a scene, like whether it's a farm or whether it's a hotel building, stuff like that. That's what Recognition is all about. The next one is Amazon Poly. So if you ever want to go from text to speech, which is why it's called Poly, then this is the service that you would use. You can choose different voices. You can also play with a playground in the AWS console to do that. Fully managed service, don't need to worry about anything. Same thing with Recognition. The next one is AWS Transcribe, which is that if you have an audio file of people talking and you want to convert that into text, then you would use Transcribe. And it also has the ability to detect different users, or if there's different actors that are talking, it allows you to distinguish between them. So really great for things like interviews, or if you're having an appointment with a doctor or something and you want to kind of put everything into text once you're done to analyze it, then Transcribe is going to be a great service to use. Okay. All right, so that's it for AI or the flavors of the month. I want to talk about application coordination right now, or PubSub, or asynchronous communications. There's a whole bunch of different items that are in this box. So let's start talking about them. The first one, probably the most important, or one of the most important, and one of the older AWS services is SNS, or Simple Notification Service. What this service allows you to do is to set up what's called an SNS topic. And you as a topic owner can subscribe different applications to your topic endpoint. And how this works is that you as the user will send or publish a message to your topic. Maybe it's a JSON object in the context of an online app. Maybe it's like an event like, hey, someone placed an order for a new iPod, something like that. You as the SNS topic owner would broadcast a copy of that message to all of your different subscribers. So this is a way that you can share information with clients asynchronously. Now, what's a use case for this? maybe you have like a fraud detection service up over here, right? So a fraud detection application would be listening for this message. Maybe you have an analytics application over here, so you need to listen for that message. Maybe you have a kind of a fulfillment workflow down here, so you need someone to basically start fulfilling the order once it gets placed. There's a whole bunch of different ways that you can set up SNS topics to work with your applications, but that's what an SNS topic does. All right, let's get rid of all this junk so we can move on. Now, in addition to the SNS topic, we also have an SQS queue, and a queue allows you to receive those messages in kind of like a holding ground. So say, for example, you have a queue here, messages can get put in it, and these messages kind of sit here until someone pulls the messages off the queue in order to process them, right? And you can set up either FIFO queues, in which case this one would get processed first, and then this one, and then this one. Or you can just set up standard queues, which the order is tried to be guaranteed, but it's not consistent. Now, SQS queues are great for event processing because it allows the kind of consumer of these messages, if you are processing them, you're called the consumer, to decide the rate in which they would like to consume them. So there's no back pressure as a result of someone trying to hit your API really, really hard. If that doesn't make sense to you with SQS and SNS, you can check out some of my videos on it. I talk about it a lot on my channel, but it's a very common pattern that you'll see in AWS. It's called the pub sub pattern, okay? Now, another popular service in this world is Amazon Event Bridge. Now, Amazon Event Bridge, there's a lot actually inside Event Bridge. There's a concept of a message bus where, similar to SNS, a publisher will put messages onto the event bus, and then different consumers will pull these messages off the event bus. Now, one detail that makes message buses useful is that you can hook into a variety of different AWS events, right? So if you have like an EC2 instance starting and stopping, you can set it up so that that event gets broadcasted into the event bus. You can't do that with an SNS topic. And then event buses also support things like schemas or patterns for different types of messages, so that you as a consumer, if you're over here trying to read a message, you can discover what the inputs and the outputs look like and what the details of that message are. So you don't need to guess, in other words, okay? So that's what an Event Bridge event bus looks like. I honestly don't use it a lot. Some people do. I prefer to use SNS because it's kind of more low level and more familiar to me. But that's what Event Bridge event bus is. Now, Event Bridge also supports two other important things I wanted to talk about. One is called rules. And rules allow you to basically set timers and say, I want to fire an event every 1 minute or 5 minutes or once a day, right? And these events can trigger things like trigger a Lambda function, for example, or they can trigger by putting a message into a queue that you can process later, okay? So anytime you need to set up like recurring events, kind of like a cron job, then Event Bridge rules are going to be what you want to use. Now, the second thing that's worth talking about here is Event Bridge Scheduler. Okay, another very underrated but important feature. Now, rules allow you to set just monotonic timers that are repeating at every interval. Scheduler allows you to set an event at a specific time in the future at a particular moment, right? So say this is like 6 p.m. on a Thursday, for example. Where this is useful, imagine you have a workflow where a customer kind of places an order in your application. So maybe this is their box. And after it gets shipped, you want to send them a notification maybe 3 hours later, right? Like by default, 3 hours after the order gets placed, you want to send them a notification saying, hey, your order shipped, you should expect it soon. You can set it up so that you invoke the scheduler API to publish a message 3 hours after, and that when that message fires, you can trigger, your Lambda function over here, and then you can go ahead and send out that email. So if you want to have dynamic events that fire at specific times, and then once they fire, they go away, that's where Event Bridge Scheduler comes into the picture, okay? All right, so let's keep it moving here. Next, I want to talk about AWS step functions, which are, I would say, my second most favorite AWS service. And step functions allow you to create different workflows. So you can say like, I want this task, and then after that task, I want to do this task, and then I want to do these other two tasks in parallel, right? And then once those are both done, I want to join the results back in this next task. These are the types of operations, the types of things that you can do in a step function. So it's really a distributed graph where you can say, I want to do this stuff in this particular order. You can also have if statements or conditionals here. So you can say like, if this case is true, then go in this direction, else go in this direction. There's also failure handling. So if this kind of fails, then you can take this path, for instance. There's a lot that you can do with step functions. I also have a course on step functions where it's a master class, extremely powerful AWS service that's also very integrated with all these other AWS services too. So if you're interested in learning more about step functions, highly suggest you to check out my course. I'll leave a link down in the description section below if you want to check that out. Now, another workflow style application in the world of event or application coordination is MWAA, which is Apache Airflow. So Apache Airflow is another kind of managed graph or workflow-based service. However, this one is open source. So if you're concerned with getting like locked into the AWS ecosystem, if you use step functions, then go ahead and go for Airflow. Honestly, I love step functions. They have a very excellent ecosystem. I would suggest them over Apache Airflow every single time, but that's just me. All right, so let's keep this going. Now I want to talk about data processing in analytics. Okay, so say you have your API or your endpoint, your API, your compute layer, and you're saving that into your databases and stuff. You're using AI engines to actually like do intelligent things, and then you're coordinating communication with other services and application coordination. Now we want to like crunch our data and develop insights from it, right? So typically what you'll see is the first service that people use to store the raw data is Amazon S3, right? So Amazon S3 is a block storage, as we talked about earlier. I kind of mentioned it over here that I wanted to touch on it a little bit later. However, it's very useful in the context of just general file storage for analytical and data processing workflows. And the way you'll typically see this set up is that someone will deploy their data into S3, and then you want to process it. And there's different ways to process it. The first and popular way is using EMR or Elastic MapReduce. So if you're a MapReduce user or Hadoop user or Iceberg or anything like that, and you want to use EMR to parse your data and process it and develop insights so that you can store them elsewhere, then EMR is definitely going to be the service for you. Okay. Then there's also AWS Athena, which is a very popular analytical service to basically run SQL on all of your data. Now, the great part about using Athena over something like EMR is that with EMR, you process your data, then you need to put it somewhere. Usually you put it back in S3, right? But with Athena, you can just read off of the data in S3 itself. Okay, and you don't necessarily need to save the results anywhere. And so the reason that's useful is because in EMR, you need to set up different nodes, right? You need to have a cluster, and then there's different compute costs that you need to run up if you're using that. But with Athena, you just basically go directly to S3, and then behind the scenes, the Athena team sets up different compute nodes for you right here, and then it kind of parses all of your data and then returns the results to you. Okay, so that's what Athena is all about and why it's more preferred in some use cases over EMR. Then in terms of just general data engineering, AWS Glue is going to be really popular for you. So this is where you can manipulate different data sets in a very managed and intelligent way, completely serverless as well. So no servers to manage. You don't need to worry about cluster size or anything like that. There's also a Glue Studio where you can register your different data attributes to your users and they can kind of see what's available to query on. Very, very powerful for analyzing, transforming, and delivering your data back to a cold storage. Okay. Now, for those of you that are kind of more industrial or in large organizations that want to run analytics, then Redshift is going to be your solution. So Redshift is a columnar database. Keep in mind, it's extremely expensive. So don't go down this path unless you're kind of, like I said, a large user, or you have many hundreds of users, for example, that want to run very large analytical workloads. Then Redshift is going to be the right solution for you. So this tool is all about scale, all about efficiency. If you have tons of data, tons of users, then you're going to want to look into it. Otherwise, look elsewhere because I guarantee you the cost is not worth it. Okay, so once you have your data analyzed and available to query, then you want to interact with it. And that's where Amazon QuickSight comes into the picture. Okay, so QuickSight is kind of like Power BI, if you guys have ever used that. So it allows you to kind of transform, set up widgets, tables, insights, that kind of stuff. And you can use it either, well, multiple different ways. You can integrate it with an existing Redshift cluster. You can also integrate it with your data that's stored raw in S3. Very, very popular for kind of end users that want to analyze your data and do pivot tables like business intelligence, these kinds of things. That's where QuickSight comes into the picture. Oh, sorry about that. Okay, one last service that I wanted to talk about in this category is Kinesis. And Kinesis, it kind of doesn't really fit into this picture that I've drawn so far. But what Kinesis allows you to do is to ingest massive amounts of data into the AWS cloud. And then from there, you can send it into what are called data streams, which are basically these pipes that you can read off of. Or you can batch it into chunks using a service called Kinesis Firehose. So every like 5 minutes, for example, you'll chunk the data and then deliver it to S3 and then chunk it again. So you want to kind of batch it into smaller pieces that are more manageable and in a predictable size. That's where Kinesis comes in. And then the last use case is if you want to perform analytics on that data in the stream. So you kind of want to say, okay, within this time window, you want to run a SQL query to say like what happened on this data. So useful for like telemetry, if you have like vehicles or you have like orders that you're intaking into your Kinesis stream and you want to say like, what are all the orders within these time ranges or within this period, for example. That's where Kinesis comes into the picture, okay? All right, so we're done with data processing and analytics. Now I want to switch gears slightly and I want to talk about monitoring and logging because we haven't talked about that at all so far, but it's extremely important with AWS, right? Like how do you actually get visibility into what's happening with all these different AWS services, right? And so that's where the monitoring and logging services come into the picture, okay? So the first one I want to talk about is CloudWatch. And CloudWatch is the most popular, most useful monitoring and logging services on AWS. If you're using AWS, you will be using CloudWatch regularly. I guarantee it. And there's a whole bunch of different features that are embedded in CloudWatch that I wanted to run through really quick. The first one is in terms of logs, right? So if you have like log data, you can send your data into CloudWatch, then you can read it. You can run kind of a SQL-like queries on it these days through a tool called CloudWatch Insights, okay? Now also in CloudWatch, there's the ability to create dashboards, and dashboards can have different widgets based on the different metrics that you'd like to analyze, okay? Metrics are just kind of time-based information like number of invocations in the past 3 hours, right? You can have a chart that, you build that kind of shows that data over time, right? So that's an example of a metric. Then you can also have things like alarms. I don't know how to draw that, but like say it's some kind of notification. So when a metric, say you have a metric that's like kind of normally like this, and then it goes up like that, you can have an alarm to say when your metric goes above a certain threshold, then fire this alarm and then send some kind of notification, okay? So that's what CloudWatch is all about. Those are the main features of it, the logs, the dashboards, and dashboards plus metrics and alarms. It's mostly used for monitoring and logging the applications that you build. Now, if you're looking to monitor access, so access-based logging, that's where CloudTrail is going to come into the picture. Now, CloudTrail, different than CloudWatch, even though the name is similar, it gives you audit logs of users or applications that are performing actions on your different pieces of infrastructure, okay? So say, for example, you want to know who created a Lightsail instance. Well, when someone creates that Lightsail instance, a log entry is going to be created in CloudTrail, and then you as the user can go and look at that later, okay? So that's what CloudTrail is all about. It's more of a management and governance logging-based service. Now, the next one that allows you to kind of keep an eye on your infrastructure and ensure that different rules or policies are being followed is AWS config. So say, for example, you want to ensure that every S3 bucket that gets created has public access disabled. You can create a policy in config to say, detect this kind of scenario and raise an alarm if this scenario is met. Then you as the user will go somewhere when that alarm fires and presumably do something about it. So that's what config allows you to do. And then the last monitoring and logging service that I wanted to talk about is AWS X-Ray. And X-Ray, like the name kind of implies, is more about profiling of your application at a lower level. So you can get things called traces, which give you, it's kind of like a line graph of, okay, your application did this, and then it did this, and then it did like this next thing, right? And like maybe the first operation was a DynamoDB read, second one was some kind of application logic, third thing was some kind of write operation to a database. You can get details about all these different operations in a visible like dashboard that's very easy to understand, and then have all that information available to you at hand to do debugging and diagnostics to understand how your application is performing, where are the bottlenecks, things like that. All right, so now I want to talk about CI/CD, right? We talked about kind of building applications, but how do we actually get our stuff into the AWS cloud? How do we get our source code in there, right? So the first tool that we use is Code Build, and Code Build allows you to build your application, right? So it allows you to add like unit tests into your source code that say whenever a new source gets committed, I want to automatically run these unit tests. I want to build the artifact, and then I want to deploy it somewhere, right? That's what code deploy is. If you want to deploy your code onto an EC2 instance, for example, you want to deploy it onto a Lambda function, or you want to deploy it elsewhere, that's what code deploy allows you to do. And then if you want to set up a pipeline, for example, like your pipeline first goes to beta, then it goes to gamma, then it goes to prod, and some kind of intelligent tiering or intelligent deployment practices, that's where code pipeline comes into the picture, okay? So these are the three different CI/CD tools that you have at your disposal to integrate with source. So it could be GitHub or Bitbucket, whatever, I can't remember the names of them these days. There's so many new ones popping up. Anyways, you integrate your source code and then build it, deploy it, and then your pipeline kind of stitches the whole thing together. Now, moving on to the topic of how do we actually kind of create this infrastructure, right? Like one easy way is you go into the AWS console and you start clicking stuff, right? And you create your databases, you create all your stuff. But the problem with this is that, if you need to expand your application to a new region, then you need to repeat all those steps. Who the heck is tracking this? Probably no one. And how do you actually even ensure that you have exactly the same configuration in your new region, right? You're probably going to miss something. All right. So that's where infrastructure as code comes into the picture. Now, with infrastructure as code on AWS, you have two options really at your disposal. You have CloudFormation at your disposal. And what CloudFormation does, this came before the next thing I'm about to talk about, just FYI, is that you write these JSON or YAML files, and they're called template files. And they basically specify all the different resources that you want to create as part of this CloudFormation template, as they call it. Now, within it, you can have a template that says, create an RDS database, create an EC2 instance, create a Elasticache cluster, for example. So you can have all of this stuff located in one file. And then when you upload it into CloudFormation, CloudFormation then reads that file and then goes out and creates all of that stuff for you across the AWS ecosystem. Okay. So extremely, extremely powerful. You can then put this content into your source code, for example, and then have it so that anytime someone makes a change on source code, you can trigger a code build, which triggers a CloudFormation deployment. And this can do some very interesting things for you so that you can basically automatically deploy different AWS infrastructure changes through code changes and have that picked up by this combination or this kind of orchestra going on here in the CI/CD world. Okay, so that's CloudFormation. Now, the problem with CloudFormation is it kind of sucks to use as a user, very cumbersome. It's very easy for files to get enormous and to lose track of things, to be honest. And so to improve this, that's where CDK or Cloud Development Kit came into the picture. Now, CDK does all the stuff that CloudFormation allows you to do, except that you can write your infrastructure as code. So you can use like Python, for example. You can use Ruby, you can use Java. There's like all these different languages that are supported. That also means that you get access to primitives and constructs like if statements and functions and all the reusability and goodness that comes out of those things. Okay, so that's where CDK comes into the picture and why it's so much more popular than CloudFormation these days. just because it's easier to use. Now, moving tangentially to developer productivity. Okay, so how do we make ourselves better developers so that we can deploy stuff faster? So the first tool that you have at your disposal is AWS Amplify. And Amplify is kind of like, what's the best way to say this? It's like AWS for dummies, I guess. So you can use like what's called the Amplify CLI, and the Amplify CLI makes it so that you can run commands like build web app, and behind the scenes Amplify will go out and create a database for you. It'll create an instance of compute for you. It'll create a load balancer for you, or a DNS endpoint, like all the stuff that you actually need to build that application. Then you can say things like add auth, and then it'll go out and add a Cognito user pool. It also has an SDK with different UI elements and different constructs that make it easy for you to deploy that stuff and get started very, very quickly. So if you're prototyping an application, highly suggest for you to try Amplify. It just makes your life a lot easier. However, a lot of people complain about Amplify because once you kind of grow out of it and you realize, hey, Amplify is just doing stuff on AWS for me, but not telling me about it, people end up wanting to just go and do that thing themselves, like create the S3 bucket, at which point it gets a little bit hairy to deal with. So if you don't want to deal with that kind of conversion pain that you may get later when you grow out of it, then just skip Amplify altogether. But if you want to experiment and do things quickly, then fine, it makes sense. Now, another service that's worth mentioning here is AppSync. So if you're a GraphQL developer and you want to, set up your resolvers and all that kind of stuff, you don't want to worry about hosting them yourselves on the different compute ecosystem or services that are at your disposal. AppSync allows you to do all of that in a managed way, so you can very quickly deploy apps and get started there. I'm not a big GraphQL guy, so I can't really speak too much about this, but for those of you that are, this may be an option worth pursuing. So the next one is workspaces, which effectively allow users to interact with like an AWS workspace, for example, using their home hardware. So you can set up a VPN so that the user can sign into that workspace. Then they can, presumably that workspace has a bunch of software pre-installed on it that the user can use. This is more about like end user computing. Okay. Now, Amazon Q, this is kind of another one that's very up there, similar to Bedrock. So Q does a whole bunch of things. The most popular thing it does is that it integrates into your IDE, and it gives you autocomplete. And there's also like a chat box thing that you can use where you can ask it different questions about like your code here, and you can use it to talk about resources in your AWS account as well. Okay, so that's what Amazon Q is all about. It's really good from just a developer efficiency perspective. The autocomplete is not bad, I gotta say, but sometimes it gets a little bit annoying. Now, another one that I just recently made a video about is called AWS MCP. Now, this isn't a service. This is a feature that's developed by AWS. What this thing allows you to do is to use an LLM. So you can say like, tell me all the files in an S3 bucket in natural language via a chat box. And this AWS MCP, also called Model Context Protocol, will query your different resources in your account. Okay. Kind of dangerous. It's like giving a knife to a monkey. You probably don't want to use this, but it is worth noting that MCP and Model Context Protocol, the way that we interact with LLMs, is an evolving space. I expect this to be a pretty popular way to interact with AWS going forward. If you have any hesitations about it, go check out my other video, but just keep in mind that it could cause some security headaches for you, okay? Now I want to talk about permission and identity management. This is something that we haven't really talked about yet, but we definitely need to because it's important. So the first service to know about is Identity and Access Management, or IAM for short. So how do we control what permissions an EC2 instance has, for example? Say we want to give it the ability to talk to an RDS database. How do we do that? Well, IAM is your answer. Okay, it allows you to set up things called users and roles. A user is more like a person, right? And a person can log into an AWS account, do some stuff, and then like log out. Presumably they're done. And a role is kind of like a construction hat, right? It's kind of a predefined set of permissions, and a role can be assumed by different pieces of infrastructure, right? Different pieces of infrastructure. So you can create a role like Lambda execution role, and this role can have the permissions to like talk to different databases or different tables within that database. That's what IAM allows you to do, right? You can create policy statements, attach them to users, attach them to roles, and basically control who has access to what in your AWS account. All right. And then also pairing with that is user management, and that's where Identity Center comes into the picture. So if you're coming into AWS, you probably have some other kind of concept of user pools. Maybe it's in like Google Workspaces or Okta or some other kind of identity provider. Maybe it's one that you've built your own. That's where Identity Center comes into the picture. So you can link those into AWS and then link the different users within Identity Center to different roles or AWS accounts or users or groups, and then control permissions that way. Okay, so that's what Identity Center is all about. All right, last topic to discuss really quick is cloud network management. And the first topic I want to talk about here is VPC, or virtual private cloud. Now, virtual private cloud allows you to carve out a subsection of the AWS cloud and make it completely dedicated to your resources. So say, for example, imagine that this box is the AWS cloud. And what a VPC allows you to do is to basically create a little bubble within that cloud. And then say this is another bubble, some other users. Now you are both completely separate from one another, right? You deploy your infrastructure into your VPC and I deploy my infrastructure into my VPC. These two things by default cannot talk to each other. Okay, so that's not possible. The whole point of VPCs is all about security and containing the blast radius in case of any vulnerability or any user that gets into your cloud network. Okay, so that's a very high level summary of what VPCs are all about. Next is VPNs. Now, say you're at home, right? You have your house here, and you want to be able to access your VPC in AWS. Well, by default, you can't do that. You can't go directly to the VPC and say, hey, let me in VPC. There is a way, but it's not a secure way. So the secure way to do that is to set up a VPN, so that you probably use some kind of VPN software before. They're very common. So that you set up a tunnel in your VPN, and then you can connect to your VPC. And then from your home machine, you can do things like talk to a database using pgadmin or MySQL dashboard, things like that. So that's what the VPN service allows you to do. And then lastly, there is Private Link, which allows you to set up communications between different VPCs. And also, when you have a piece of infrastructure that's located inside a VPC like we have here, and it wants to talk to another AWS service, because of the security constraints that VPCs place upon you, that's not possible by default. So you can set up the ability to do that with a Private Link configuration. Okay, so these are the most important AWS services. I hope this video gave you a good view of some of the things that you may need to learn or may already be familiar with. If you want to gain more practical hands-on skills by applying AWS to practical projects, I highly encourage you to check out my courses at courses.beabetterdev.com. If you have any thoughts or comments on the content or maybe things that I missed, please let me know down in the comment section below. And thanks so much for watching. I'll see you in the next one.